the first quasi-passive 2 degree of freedom ankle alignment prosthesis. It's in fact not a whole prosthesis, it's just this stack here, the ankle component, and it can attach to any prosthetic foot. The reason we want to design a system like this is twofold. First, we can actually, in theory, adapt the angle of the foot in 2 dimensions to match the ground that you're walking on. So if the foot can detect that you're going uphill or downhill or on stairs or on a side hill lie, it can actually adapt the ankle angle to match it. The second reason is that amputees in general are a little bit unstable when they walk, and they have particular trouble with uneven ground. And I have a hypothesis that we're going to use this to investigate, namely that amputees tend to get detrained on balance by living in a smooth environment. That is to say, by walking around in buildings, sidewalks, and streets all the time, they lose habits that would keep them stable on an uneven surface. And therefore, we're going to use this device to continually perturb the ground underfoot effectively and get them to use strategies that will be more stable when they in fact go off-road. There are a lot of details to work out and how that implements in the end, but this is the first step towards making these adjustments in 2 directions that will enable us to do both the experiments and the further development.
Our goal was to have a robotic ankle that would give 2 degrees of freedom, plus and minus 10 degrees, either on the x-axis or on the y-axis. So we had a whole range of freedom. We have these 2 cylinders. This one is the white one and the yellow one. And as you can see, they are cut in a 5 degree angle. And with that, we can combine those 2 inclinations to get a plus and minus 10 degrees of freedom. And we can do that and in all the range. If we spin both of them at the same time, nothing will happen. But if we spin them on different directions, you can see that we can get 1 axis rotation. And if we achieve the inclination and spin both of them together, we can find different positions for the ankle. This motion is going to happen while we're taking the step, so we'll have the time while the feet leaves the ground until it touches back the ground to reposition the cylinders and to get a new angle for the ankle. The function of the motor is just putting the cylinders in the right position, but once the person steps on it, the weight from the person itself will hold everything in the right place. We have designed it to require really small motor. With that, we can use a really small battery, which helps a lot when we are trying to reduce weight. Right now
So it's not really our purpose to wave it around like that long term, right? It's just to make a discrete adjustment and then set it once per swing phase.
Exactly. So I'm going to disassemble the prosthetic ankle now to explain how it works. Since we have such a simple design, everything is basically held down by 2 screws. There's the top one and the bottom one right here. And they are attached to a U-joint that basically clamps everything together. So here we go. Here we have the pyramid adapter that could go to any pylon. It's a standard prosthesis. We have some spacers to achieve the right height, not to have too much pressure on the top of the cylinders. And as you can see, it's basically really simple. We have here both cylinders. They're supposed to be the same. They're not quite the same because we had to 3D print them, but once we machine this, they will be the same part. Here we have a standard U-joint with just we're planning to buy a regular one from the store and then machining it to fit properly into the base. This is the base. It basically is the end of it, so we have the same part on the top and on the bottom, and it's supposed to be the clamp everything together and attach to the feet and to the pyramid. And this gives us the angular freedom that we need, and the cylinders sets what angle it's gonna be. And basically how it works is that this holds the traction force and the cylinders will hold the compression force, and with that we can hold everything together. And if we have a moment on the front of the foot, everything will be held together with traction and compression here. We have the spacers here that hold the spacers and the motor mount. They basically hold the motor in. We made the spacers long so we could fit into the prosthetic feet and to fit into a adapter, like a boot that we could try it on. And on the final design, we're gonna have a considerably smaller spacers so we can make everything lighter and more compact. And basically this is it. It's a pretty simple couple of pieces that when we stack together work perfectly for our goal.